Good afternoon, everybody, and a very warm welcome to this June series of Bite-Sized Corrosion, where we're going to be spending some time looking at maritime corrosion. My name is Vanessa Seeley-Fisher, and it's my great pleasure to host today's session. Now, if you've stumbled upon us for the first time, you're very welcome. In every session of Bite-Sized Corrosion, we try to break down an aspect of corrosion into information that is informative and interesting and hopefully somewhat palatable. And we're hoping to make your corrosion experience easier for you to digest and understand. And we hope that by the time you leave us, you will be eager to continue your journey in understanding corrosion a little more. To our regular attendees, it is so heartwarming to have familiar friends join us each time we gather. And I'm so delighted that you've chosen to spend this rather wintry lunch with us today. As always, you're very welcome to communicate with us, chat with us. If you'd like to send us an email, you're always welcome. Now, today we start our four-part series in maritime corrosion. And it struck me as fairly interesting and perhaps a little surprising that although we all instinctively know that the sea is highly corrosive, we've not addressed this topic at all on Bite-Sized Corrosion. And right now, we're about to rectify that. Now, living in Johannesburg, although it's freezing cold, my acquaintance with the corrosive effects of the ocean have largely been restricted to kind of textbooks analogies and also rusty components when we've gone to seaside holiday accommodation. Now, today, I'm delighted to welcome John Lusty to the microphone. Unfortunately, John's camera isn't working, but John has an electrical engineering background and a fascinating man. He worked with the Hermanus Magnetic Observatory based in the Naval Dockyard in Simonstown and has gathered much information from his association with the Navy and has very kindly and graciously agreed to share some of his experiences with us. So a very warm welcome to you, John, and thank you for joining us. John, I know corrosion wasn't always the main focus of your work. Would you like to share with us a very brief synopsis of how you came to, shall I say, cross swords with corrosion in your working life?
Yes, good morning to everybody. I was the branch manager of the Hermanus Magnetic Observatory office in the Naval Dockyard. It's now called the South African National Space Agency, SANSA now. And our main focus was to minimize magnetic signatures of ships. That's very important in warfare because from the signature you can identify the ship. Now, you may wonder what that's got to do with corrosion. Besides the degaussing coils which they have on the ship, corrosion itself, because it is galvanic in nature, there's electric current flowing, can also affect the signature. So hence our involvement with corrosion. We had to be aware of that and get on top of that and try to minimize that. We only had I think it was a 2 or 3 year contract. So I don't have a lot of history. You'll see what in a couple of places coming up. We weren't quite sure what the final outcome was, but at least we did the best we could at the time.
That's so interesting. One doesn't think of the ramifications of corrosion outside of just rusting. And to hear that it actually can change the magnetic signature of a vessel is completely fascinating to me. Now, John, obviously vessels in the ocean associated with the Navy, one thinks of the boats, but one also thinks of submarines. And my main exposure, maybe my only exposure to a submarine actually was in The Hunt for Red October, the movie. So that's fairly restricted. But in chatting with you, it made me realize that I've never thought about the fact that we need to protect these vessels from corrosion.
No, that's correct. I think you've got a photo there of the sacrificial anode. That's quite a nice picture. That's a sacrificial anode. The silver part is zinc, and you can see it's molded onto a steel brace, I suppose, or bracket, and then that's welded to the hull. So that's quite a nice example of a sacrificial anode on a submarine, which is an example of, I suppose you could call it passive, it's galvanic corrosion control.
And it's a lovely clear picture, so thank you for that, because often we don't get good pictures of corrosion protection. Now, one of the aspects of the submarines which you introduced me to were transducer array drums, which I thought was very clever of me to even figure out how to say it. And for the uninitiated like me, please can you explain what a transducer array drum is, what it's used for, and why you would be concerned about it in terms of corrosion?
Well, submarines, as you probably know, rely very much on sound, on sonar. That's how they pick up enemy ships, and they keep listening, and they themselves have to be very quiet. So you have what is called a sonar transducer array, which is mounted underneath, and in there's a plethora of very high-tech electroacoustic transducers. And those are all obviously wired back into the submarine, and there's a complete section of the warfare suite which is dedicated to sonar. So all these transducers are mounted in a watertight drum. And these pictures here now that you can see, it's an example of the transducer array drum itself that encloses the arrays. On the center, you can see a reasonable example of a drum. There's a little bit of corrosion there where your cursor is. On the left is an example where corrosion actually has set in further, and in fact, the braid is not there anymore.
Right.
And on the right, we've got just another view that's like the flange where the drum gets bolted onto the hull of the submarine, and you can see there you've got examples of corrosion as well.
So all of this corrosion is obviously something that you would stop. And did you figure out what the corrosion was being caused by and how to stop it?
What you have to do is make sure that the drum itself is electrically strapped to the main hull. You'd say that's earthed. And there's an example of what it should like. You can see that braid is in very good condition. But once that connection goes and corrosion starts to set in, then you find corrosion of the drum will start. And that's a maintenance issue, just to keep that intact.
And I suppose that would have been your recommendation to the Navy, that, you know, keep these metal braids looking good, and
absolutely,
corrosion will stop. Right. That's so interesting. Now, the other sort of aspect about submarines that when we were chatting before this was about getting into a submarine. And you mentioned that pontoons are often used as a way to access the submarine. So let's start right there. Again, for the uninitiated, of which I definitely was it. Let's tell me, what is a pontoon to start with?
A pontoon is a floating quay. Quay, quayside.
Right.
It's a floating quay that you can bring up alongside a vessel if, for whatever reason, you don't want the vessel in port. So it's a general purpose unit. It can be used for submarines. It can be used just for normal surface vessels. And it's got a system of flood chambers where you can control the amount of water in each chamber, and hence you can control the height above the waterline. So it's quite a nifty little thing, very simple in principle. But here's an example now where this floating pontoon was alongside, but it's very important that it is earthed. Otherwise, you start to get galvanic corrosion between the floating pontoon itself and the quayside. And this is actually what had happened. You can see there's a very even distribution of brown. There you go, all the way down that side. And that's a classic example of stray current corrosion.
Yeah.
And I think that you've got another view showing underneath how badly pitted it can become. There you go. You can see it's not only down the side. You know, that's a very good picture. It gives you a good overall idea of what's happened there.
And little holes like that can cause dramatic challenges, because obviously that's now going to cause a whole flooding issue that prevents this from being used.
In fact, I didn't want to put it down on paper, but what actually happened was this pontoon sank because it became totally flooded, and they lifted it out with this huge crane they got in the harbor, put it up on the quayside and repaired it, and they refloated it, and now it's fine. It was fine. It was very, very well repaired.
It is interesting, and I think it's a good takeaway for all of us, is that if you know that you've got the opportunity for corrosion to occur, and in this case, the stray current interference, then a simple earthing mechanism, a strap or a cable, can really solve the problem. And we've spoken at length on bite-sized corrosion about stray current challenges along pipelines, and using an earthing cable to drain those stray currents back to wherever they're intending to go. And it's exactly the same in the ocean. And of course, the sea is such a wonderful electrolyte. Your currents are flowing easily. So we do need to take that extra care. But
This
when
was
we
quite
carry on.
Sorry, this was quite graphically demonstrated because we took a walk down there once when it was back in the water, and we wanted to see what earthing arrangement they had. They just had a cable coming out from the workshop across the quay, and it just a little, almost like a vice clamp on the onto this pontoon. And we said, no, this is not adequate. You've got to get a really good cable and a really good connection. Otherwise,
Yes.
you're going to get the stray current corrosion.
Yes, and of course the challenge with the cables is, as you rightly say, is you don't want any kind of dry joint scenario. So a welded connection is always better. But that's so interesting. Thank you for sharing that with us. And it's lovely to see practical examples of problems and solutions. Now, obviously, submarines are not your only area of experience, John, and you mentioned to me that you've had some experience with the corrosion of propeller shafts on a frigate. Now, as far as I know, the majority of ships, or big ships anyway, use an impressed current cathodic protection system for the part of or all of their corrosion control. Was that your experience as well?
Yes, we had an issue on board the frigates, which were using an impressed current cathodic protection system, or I call it an active system, and it wasn't working properly. We went down right to the engine room, and if you think of the shafts, they go out the back through a gland. Okay, so that doesn't make any direct contact with the ship at the gland hole, the orifice there. So they have to be earthed by another means, and because they're turning, we use a system of slip rings. So you've got a system of slip rings, but now actually what had happened in this instance, due to, I think, something had happened, there were some very corrosive liquids coming out of something close by and causing severe corrosion. And as you can see that, I mean, you're looking at the actual propeller shaft itself there, and you can see those slip rings are not making very good contact. I mean, look how dirty that area is, that ring. And you can see the rest of the shaft also there's rust there as well. So this was something that we found and said, no, you've got to get this right. In terms of the final outcome, I mean, our recommendation was that this really has to be addressed. They probably had to get the OEM back in to rectify that.
I think that it's also worth continuing to keep in mind that in a maritime application, the environment is so corrosive that a lot of maintenance is required at all times. And I know when thinking about the Navy, one just thinks of, sparkling brasses and so on, and that active removal of the corrosion products all the time is so important. I know that's for visual effect, but kind of below water or in the hulls where you've got parts of steel, you do need to make sure that you are maintaining them adequately. And one hopes that they do. You did send to me a photograph, which I just want to share, of the impressed current control cabinet. And it's encouraging to see for those of our audience who are familiar with impressed current systems, that even in the ship, the transformer rectifier controller is pretty similar to those we see on shore, whether they be on pipelines or tank farms and other infrastructure we're trying not to corrode. And this is obviously just the control panel, but behind it sits the conventional transformer rectifier. And again, just encouraging to see that the technology, although differently applied, is the same across all the various applications. And we're all in the same intent, which is trying to stop corrosion. Now, John, I'm aware that our Navy doesn't have a very vast number of enormous ships like the frigate Challengers, but actually the majority of the vessels that the South African Navy have actually are much smaller, primarily as patrol boats. Now, I'm sure they must also have cathodic protection, but is this largely impressed current, or is it largely sacrificial?
Okay, the harbour patrol boats are smaller vessels, as you've said, and no, this is a passive system, just conventional cathodic protection with anodes. And what we did was we took a silver chloride reference electrode, which I'm sure everyone here is familiar with, and we measured what the potentials were. This was one particular boat which seemed to have a problem, and the voltages should have been between minus 950 and minus 1100 millivolts, and most of the boats were fine, but there were one or two where it was slightly outside this range, and we noticed that the anodes were very badly corroded. So we just recommended fit the new anodes. They possibly were of the wrong material, but after they did that, we measured again, and the potentials were within the correct limits. So that was a very good, very good illustration.
It's encouraging with sacrificial anodes that they kind of give us instant results. So if you're using a zinc electrode, which is often what is used in an offshore application, you would be expecting a potential of about minus 1050 millivolts with respect to the silver chloride. So absolutely, you're going to want your steel structure that's connected to it. And there are all sorts of little difficulties that can arise. I've seen instances where the anodes have been coated on a boat. And of course, a coated anode isn't going to do anything because it needs to be exposed to the seawater so that it can corrode away and protect the boat. So there was an instance many years ago now where I remember there was quite a proud, oh, but our anodes are still in good condition. Well, they were still in good condition, but the boat wasn't.
Painted over. Yes.
So we do need to bear that in mind. And sometimes there are these almost silly applications where one should see the obvious, but we don't always see the obvious, do we? And it's important that we bear those in mind when there are difficulties. And you rightly say, you know, one boat was not adequately protected, or the anodes had depleted. One wonders if, the material was wrong, or there was an inclusion or something, a formulation of the metal alloy that wasn't quite to spec, that resulted in the anodes depleting more quickly and therefore not doing the corrosion protection job that they needed to. But it is interesting to see how, from the Navy perspective, that there's this need to protect our assets as we absolutely should. And it's encouraging to hear that there are cathodic protection. And obviously, the photographs that we saw the coating. And we must never forget that the coatings that they choose are the first line of defense against the corrosion, that they provide that barrier. And in dry dock, of course, you get to the point where they're replacing the coating first and foremost, and then just using the anodes to protect the little holidays or defects that occur in the coated surface. John, this has been most fascinating to pick your brains and to hear some of what you've experienced. And I do thank you for sharing that with us.
Oh, it's a pleasure, Vanessa.
And we've got a nice lineup for the rest of our series. So tomorrow we're going to actually be chatting with Grant Wallace. And Grant is a fascinating gentleman who's been a commercial diver for many, many years and has encountered corrosion really in the deep. And he'll also be able to share with us some of what he has encountered in terms of marine corrosion and some of the challenges that we don't necessarily think about. And I think it's important for us, largely in the engineering space, to realize that when we are designing corrosion protection systems, we need to be thinking about the practical application thereof. And so anything that's going offshore obviously has to be rugged. It has to be able to withstand that marine environment in and of itself, whilst it's doing its corrosion protection job. But as we'll hear from Grant tomorrow, we need to take a couple of other aspects into consideration. So John, I've been fascinated by our discussion, and really you've stretched me, and I've learned a lot about the Navy and ships and words I didn't know, which is wonderful, and some of the challenges with corrosion that impact big ship owners. And it is reassuring to see corrosion protection being used on our assets as in a way to maintain them. So I do hope that our audience has enjoyed this discussion as much as I have. And I wanted to just say that if discussions on corrosion are new to you in our audience, and this has been something that you've been interested in, I would like to invite you to learn some more of the fundamentals of corrosion through the first module of our online course titled Conquering Corrosion. Thank you.